Good. Yeah, so thanks for organizing this. This is a great time to kind of give a introduction and or update depending on where you're coming from on the CIS Model Intercomparison project for SIMIP6. And as Richard was saying, so I'm one of the co-chairs. Dirk Knotz at the MPI in Germany is the other co-chair, and we also have a steering committee, and their names are listed here. I just wanted to give a little introduction if this is the first time you've heard of the CIS Model Intercomparison project. So the main aim of it is to better understand the role of sea ice for the changing climate of the planet. CIS-MIP is a diagnostic MIP within the SIMIP6 context. What that means is that we didn't propose any dedicated experiments that modeling centers have to run for this MIP, but instead our main focus was prior to the runs to refine the variable request for the CIS model component, and then to facilitate model analysis with a focus on CS process understanding by having workshops and building a community to kind of push us to challenge ourselves to do more process-based CS model understanding. So we have a website that's hosted by Click, which has been sponsoring all our workshops so far. So there we post updates when things are happening, and also if you want some more information, you can go there. The three guiding questions for the CIS MIP are really, we want to understand why CS model simulations differ from each other, why the CS model simulations differ from the observational record, and what we can do to reduce these differences so that we can obtain a better understanding of sea ice in the climate system and eventually work towards getting better sea ice projections in both hemispheres. Oops, sorry. We're not just a pure model intercomparison exercise, but also see CIS-MIP as a forum for identifying the best possible use of observations for the evaluation and improvement of model simulations and the development of new process-based analysis metrics. And so that's kind of the scope, what we set out to do with the CIS Model Intercomparison project. Just a quick reminder what the state of CIS extent and CMIP models is. CIS extent, of course, is just one aspect of the CIS models, but probably the most looked at in the CMIP context. And so there was some change from CMIP3 to CMIP5 in terms of the September CIS extent, and a change in the right direction in that the model mean on average was reduced by about half a million to a million square kilometers. So it got into better agreement with the observations. But initially we didn't really know why. Only in 2016 was there a paper that suggested that the cause of that wasn't actually any improvement in the CIS physics or any changes to the CIS models themselves, but potentially just a change in the forcing. What they found was that in SIMIP3 models, only about 40% of the models included a volcanic forcing in the historical period, whereas in CIMIP5, all of them did, and that led to changes in the sea ice model simulations. So for CIMIP6, we were hoping to get a better understanding of these biases rather than just being able to diagnose them, and that's really what led to the creation of the CIS MIP. We had our first workshop in 2015, and with the goal where we wanted to kind of bring the community of CIS modelers and CIS analysis people together to think about how can we really make progress in understanding what drives this large spread in the models and what drives the biases that we're seeing. And it really became the CIS MIP workshop when it became clear that in order to do the analysis that we wanted to do, we needed more model output, more specific model output than we could get from the CIMIP5 or the CIMIP3 models. And so that was the initial scoping meeting for the CIS, new CIS variable request. And then over 2014 to 2016, we established this new CIS variable request for CIMIP6 with lots of community input, and then worked to incorporate that into the CIMIP6 data request. And specifically, what we did in the CIS variable request, we wanted to provide the model output so that we could perform the process-based CIS model analysis that we wanted to do but couldn't do from the CIMIP5 output, so that we could really understand the cause of the model biases, which is obviously the first step in order to improve any of those biases. And so one focus of the refinement was that we wanted to get all the variables that we actually need to close both the heat budget, the mass budget, and the momentum budget for sea ice, which wasn't possible from the SIMIP6 output. Another focus was more daily variables for better comparisons with observations. In SIMIP6, there are only 4 daily variables. In SIMIP6, we're now requesting 8 daily variables. So in addition to what was there in SIMIP6, we're requesting surface temperature of sea ice, the snow thickness on sea ice, a fraction of the time step that sea ice is present, and also the sea ice speed, in addition to what was there before. We decided to continue requesting all variables on the original model grid because that's really crucial in order for us to be able to close budgets. So it goes back to one of the main focuses of the sea ice request. But there was a larger community request to kind of make it easier on the modelers, on the people who want to compare output from the SIMIP5 models or SIMIP6 models. And so we also requested integrated measures. So the most widely used sea ice variables are the sea ice extent in both hemispheres, as well as the sea ice volume. So we requested for the first time these integrated measures as a priority 2 variable so that people wouldn't have to over and over calculate that. And if that's all they're interested in, they don't have to deal with the sea ice model grid being maybe not a regular lat long grid. We also worked to really carefully craft the variable descriptions and the CF names so that there was as little confusion as possible, and the community was very, very useful to really double and triple check those because there is a lot of possible confusions. And one example where we actually changed a variable definition so that we're requesting something different than before is sea ice thickness, because there was a lot of confusion in what that could mean, and there were some comparisons based on that. So for SIMIP5 and before, what was requested was the grid cell average sea ice thickness, whereas in SIMIP6, we're going to request the flow ice thickness. And what the difference is that flow ice thickness would be the ice thickness of any ice that's actually in the grid box. So the average of that ice that's actually there, whereas the grid cell average thickness also averages in the zeros for any open water areas. And that was different than a lot of the observational products, which actually gave the sea ice thickness only for the ice that's actually there. And again, also if we're comparing models with different resolution, averaging in, these zeros can look very different. And so just as a quick kind of spatial look at that, the grid cell averaged here over on the left, and then the actual thickness of any ice present in the grid cell in the middle, and the difference at the right, and that's shown for the fall. So where we have more open water area, so that's obviously where it matters. If it's always 100% ice covered, those two definitions are exactly the same. But if we have open, if we only have 90, 80 or less percentage, we actually have a difference there, and it can be up to a meter in the spatial fields. And so for SIMIP6, if you have been worked with the sea ice variable before, now the sea ice thickness variable will actually be the flow thickness. But you can still get the old sea ice thickness for comparisons to get just from the sea ice volume. So before there were pretty much 2 variables which were giving you the same information, whereas now we kind of changed what the sea ice thickness means. In 2016, the paper on the sea ice modeling comparison project was published in the GMD special issue for SIMIP6. That was a requirement as part of being an endorsed MIP for SIMIP6. And 18 modeling centers officially endorsed the sea ice modeling intercomparison project as well. And so they're all listed here. And what that meant was that they committed to provide at least the priority 1 output for the sea ice model intercomparison project for the DEC experiments. In 2017, we had our second sea ice MIP workshop, which was a 1-day workshop that we had in Bremerhaven, Germany. And there, the main focus was to think about how we're going to use these variables to really make progress in our understanding of the sea ice simulations. And so the participants kind of self-organized themselves into what ended up being 13 task teams that will focus on specific sea ice analyses tasks from the SIMIP6 model output. And so this is an overview of the different task teams that formed with the leads identified below. And we kind of grouped those into 4 different categories. 3 task teams on analyzing different feedbacks, 4 on state estimation of sea ice, 4 on variability, and then 2 on new methodology development for model and models observation intercomparisons. Then we also contributed to the metadata request for SIMIP6, which so that we can actually maybe group some of the models in terms of their sophistication in terms of the ice sheet model that they include. And so we provided some input to the SIMIP6 metadata request on things that we would like to know about the sea ice models within the SIMIP6 models. We also contributed to the sea ice remote sensing and modeling workshop in 2017, which was really useful to bring together modelers and sea ice remote sensing people to talk about useful observations, useful intercomparisons between observations and models. In 2018, we organized a session at POLA 18 on sea ice modeling and sea ice process understanding, and it was really well attended. We had really good discussions. We also had a small breakout on sea ice MIP there during the lunch. In late 2018, the first paper using the newly defined sea ice MIP diagnostics was published by Anne Keane and Ed Blockley from the UK Met Office, and so they did that within their model, but using these newly defined diagnostics that are going to be written out for several of the models for SIMIP6. And then late 2018 and into 2019, the first SIMIP6 data has started to become available. I checked on Friday, so there's now one model that has one scenario in the scenario MIP that has sea ice model output, and 3 models currently for historical. But I think a lot is going on from like their updating. So I think it's hopefully starting to become more so that it really makes sense to dive in and start analyzing those. So for the rest of 2019, we proposed the session at AMS, mainly on sea ice process understanding, sea ice modeling and increased process understanding, because we kind of were anticipating that SIMIP6 data might not be quite so available before May already. So that's for the POLA AMS meeting in Boulder. And then we also have a session at the IGS meeting in Winnipeg in August. And specifically there, we have a session on sea ice and SIMIP6 models. So we're really hoping and trying to push the community to start analyzing some of that data, and so hopefully that will become available. And part of that is that the ERA6 deadline is December 31st for inclusion in the next assessment report, and so it'd be great to have some sea ice papers submitted by that deadline. For the IGS meeting, the abstract deadline is March 20th. If you're interested in submitting to this session or any session, we're also planning to have a half-day workshop the Sunday before the IGS meeting to bring together the sea ice MIP community again and talk about the task teams, the analysis that's ongoing, and try and bring everyone together to push for writing some papers before the end of the year. Beyond 2019, we're planning to write an overview SIMIP6 sea ice paper, kind of summarizing some of the lessons that we'll have learned. That probably will not be before the ERA6 deadline. And then we really see the job of sea ice MIP to further facilitate process-based sea ice model analysis in the years to come. And just like we're seeing with SIMIP5, there's still a lot of really interesting science coming out of it right now, even though the data has been available for a long time. So we hope to further facilitate that process for the sea ice model intercomparison project. So yeah, thank you for your attention.
Okay, thanks, Alex. As you said, that you have a prior commitment that you need to go to. I thought we would take questions for you now at this point, if that's okay with you, Meredith. But before that, I just wanted to clarify the time schedule here. So you said that publications for AR6 must be submitted by December 31st of this year. Is that right?
Yes, and I just talked with Dirk Knotz, who's involved as lead author for the physical science chapter, that right now it does not look like they're going to change that.
Wow.
Despite all the delays, exactly. So, I mean, they could always still at the last minute, but currently they're holding that, and they're writing the zeros order draft is already written right now. So.
Well, for all of those contractors who shifted their vacation time to the shutdown, I guess it's going to be a busy summer to process.
Yeah.
Okay, let's open it up to some questions if there are any questions for Alex. If not, I have several questions. So that diagram of the various task groups was quite illuminating. So are each one of these groups then going to provide a separate assessment or report, or how will this work?
Well, not a report as much as probably they were going to just work to write papers. I think it's less about reports in that case than like just to bring people together who had similar interests and kind of try and facilitate collaborative work rather than competitive work in that sense as well. We have short write-ups of like kind of what's behind these very short titles on the SIMIP website for all but one of these, I think, where people kind of wrote in like 200 words, like a short abstract of what their specific area of interest is, and to kind of see if other people are interested in that. And then again, that's something that we're hoping with the SIMIP workshop, even if maybe all the data of the models isn't yet on the Earth System Gateway, even by August, maybe some informal collaborations can kind of access that data already to try and like get some analysis finished and some papers potentially submitted by that deadline.
I see.
Yeah.
In the planning for SIMIP, so you noted that there are no offline experiments. Was that ever considered?
Yeah, we talked about it, but it was mainly the timeline was too short to organize that when we decided to have a CI small intercomparison project, and we also felt that it was probably premature because we really needed to gain more understanding of what we're really aiming for. And already a lot of the things like having the same scenario and all that stuff is already controlled. So we thought maybe for the next round, if we find something that we really want to test across multiple models, we would have some dedicated experiments that we would propose. But for this round, we've wanted to focus just on trying to really be able to do some process-based analyses, lots of budget analyses to really understand some of the differences between the different models.
So you focused on the different variable conventions and things like that were assigned for SIMIP. Was there any other type of guidance given to the modeling center, such as what type of I don't know, what type of parameterizations or anything like that? Was that part of the SIMIP guidance?
No, so that every modeling center is using whatever CI's model they want and whatever parameterization. The only thing that we tried there was through the metadata request, so that we can actually understand that. So when we're doing some analyses and maybe we find some grouping that some models are doing something one way and the others, that then we can look into the metadata and see like, oh, maybe they have something, all the models that do something one way have something in common in terms of their how many ice categories they have, or what kind of thermodynamic scheme they're using, and all that kind of stuff. So.
Okay, is there time for any other quick questions for Alex? If not, thank you, Alex. Our next speaker is Dave Bailey from the National Center for Atmospheric Research. He's going to give the NCAR perspective on SIMIP's
we had discussion of the meeting, but we had discussed if the discussion runs over, we can continue the meeting a little bit. We don't have to cut it off right at the hour. Just wanted to point that out.
Okay. All right. Are people hearing me, seeing my screen?
Yep.
Yes.
That's good.
Okay, perfect. So thanks to Alex for a really nice overview of the SIMIP process and everything. And so basically at NCAR, we received this request, and as it turns out, I actually was one of the reviewers on that paper, not telling. But so I went ahead and decided that I would make a substantial effort of getting these actual variables that were requested, that they would be specifically added to the SICE model that we use within the CESM. So why Oh, there it is. Huh. All right. So Alex talked about the paper already. So this was my guidance to follow for adding the variables into our sea ice component. And as Alex said, this is just specifying the diagnostic variables that are going to be available for all of these SIMIP6 runs. I thought rather than trying to list all the variables I included, I've just added a list here of the variables that I did not include. And so there's various reasons for this. It's just, you know, maybe we don't have the physics in the model for some of these variables. Also, in some cases, there are variables that are coming from the ocean model, or they can just easily be added by multiplying a constant by some of the existing variables. So I do have an asterisk beside the salt flux at the bottom of the ice and the freshwater flux at the bottom of the ice. There was a little complication with this. It was my intention to add these, but we have the complexity in the CESM where the ocean component POP actually does the frazzle ice computation, and they compute the salt fluxes and the freshwater fluxes from that process. So originally I wasn't putting out the total salt and freshwater fluxes. And so, but I think I can rescue these hopefully, but a lot of our deck experiments have been done already. And so I'll hopefully try to add these to a request later. So just a quick summary, what are we using in our model? It contains version 5.1.2 of the Los Alamos sea ice model, pronounced SICE. And there's numerous new physics options within this version of the model. We're only using a subset of the physics. So we are using this new mushy layer physics of Adrian Turner, and he worked with Elizabeth Hunke on implementing this in SICE. We're also using this level ice melt pond scheme that Elizabeth and several others had developed. Basically, it takes into account whether the ice is deformed or undeformed, and the ponds will tend to grow in areas that are flatter. And then the other thing we've done is we've increased the vertical resolution internally in the sea ice. So we went from 4 sea ice layers to 8 sea ice layers, and we now have 3 snow layers where we used to just have 1. And then we've also gone to a salinity-dependent freezing point at the base of the ice. And so both our ocean component POP and the sea ice component see this salinity-dependent freezing point. So we're a good way through a number of these deck experiments that Alex mentioned already. So these are sort of the core experiments required for the CMIP process. So we have already a 1200-year pre-industrial control run. This is where we repeat the 1850 forcing over and over again. We've completed 9, and the 10th one is nearly done, 20th century runs. And here well, not we, but CMIP has defined the 20th century as running from 1850 to 2015. That's just because of available forcing data sets. And then future scenario runs would start 1st of January 2016 is the protocol. We do have one 4 times CO2 run. So what this means is that you do an instantaneous quadrupling of CO2, and then you run the model out for 150 years. And it won't be quite equilibrated, but it's just one of the ways to understand the climate sensitivity of a model. And then another protocol that has been asked for us is a 1% increasing scenario where you started in 1850 and you increase the CO2 by 1% each year. And it basically eventually gets up to about 4 times CO2, I think, at the completion of that run. Still to come, we're nearly done the one additional 20th century run. We've got a couple more 4 times CO2 and 1% runs. And then we started some of these future scenario runs, which are now the shared socioeconomic pathway or SSP scenarios. They used to be RCP and whatever before that. So they have to keep changing it up. One of the projects, and I didn't see this on Alex's slide, so I'm curious to hear her point on this, but Ed Blockley had approached us about starting an overall SIMIP mass budget comparison between all the models. And in her slide, it was surface energy budget. So I'm not sure where the discrepancy is there, but we're still in the planning stages where we're trying to assemble the data sets required for these. And actually, we haven't actually published any of our data yet. Part of what Alex alluded to, this metadata request, actually took us a significant amount of time to put that metadata up on the spreadsheets. And that was done last Wednesday. And that was a prerequisite before actually publishing any of the data. So we've now got the metadata up, and we'll soon be pushing the data we have available up to the Earth system grid. And just to highlight the fact that this is generally, I think, falls under the category of performance element 3.2.1, which is, developing models to understand the physical processes within sea ice and so forth. So I've added just a few quick pictures here of some of the results from our runs. You can see that actually our ice thickness present day is very thin in the leftmost panel here. In the new runs, this is actually different than our prior runs where we were a bit thick present day, which is kind of interesting. But, we've got a number of diagnostic fluxes, as I described, coming out. So I'm just showing here this sort of frazzle ice growth that we have in the model, and then also just the general concentration compared to the NSIDC observed concentrations. And I think that's basically it. So I'd just like to leave it open for questions at this point, and I'll give it back to you.
Okay, thanks, Dave. So let's go on to Mike Winton's talk, and then we can have a discussion then after that. So Mike, thanks very much for presenting today. Are you ready to show your talk?
Yes, I'm ready. Let me get it up here.
Okay, can I ask a question?
Let's just hold off on the questions until after Mike's given talk.
Sure.
Given talk, if that's okay.
Yeah.
Right.
All right. Hopefully everyone can see me and my screen. More important to see the screen, I guess. I'm going to be talking about GFDL's SIMIP6 effort, comparable effort at GFDL to what Dave just spoke about for NCAR. So just a little bit of background on our models. In the post-Manabe era, in the 2000s, we created a model, CM2, for the 2007 IPCC report. And between that report and the 2013 report, there was a great branching of the model tree at GFDL. We made high resolution models, models for forecasting, Earth system models with 2 different ocean components, and then a model that included atmospheric chemistry and the aerosol indirect effect, CM3. And this latest phase for us has been sort of a pruning of the branches. And so we have, out of this sort of group of models, we've created 3 closely related models based on the same code and having very similar capabilities, but really with different emphasis. So we have SPEAR, which is our forecasting model intended to replace our floor CM2 based model. And then two models which are producing data for the SIMIP6, CM4 and ESM4. And CM4 and ESM4 are being run right now and will produce data and deliver it to the repository this year. CM4 has run through its deck, what we call the Deck Plus, which includes the historical experiments. And we're starting to deliver some data. There's actually some PI control data already at the repository, and ESM4 is currently running the deck. So nothing is delivered from ESM4 yet, but it'll follow closely on the CM4 in the repository. So this is a table of the sort of the resolutions and capabilities of the two models. They both have 100-kilometer resolution atmospheric models, but there's additional resolution in the stratosphere in ESM4 for the purpose of predicting ozone. Both models do sufficient aerosol chemistry to produce aerosol concentrations from emissions of precursors. And they both do the aerosol indirect effect. The ocean model is higher resolution in CM4. It's a 1/4 degree, so now we're into the eddying regime, although not fully eddy resolving. Both models carry ocean biogeochemistry. There's a simplified biogeochemistry in CM4, but we haven't decided whether we're going to deliver that to the database yet. We're going to have a look at it first, so it may not be there this year or ever, I don't know. But anyway, we have that capability within the model. Both models have dynamic vegetation land models. The CM4 is kind of based on our previous generation of land model, and ESM4 uses a new generation of land model. And then both models use SIS2. So our CM2 and CM3 series both used a sea ice model called SIS, which we've upgraded to SIS2, and I'll show you what that means. Basically, we've replaced the albedo parameterization with a radiative transfer calculation and increased the layer structure from the Centner 3-layer formulation to 5 layers. Basically, we're following size 4 here, but but of course there's size 5 now, so we still have some further development to do to catch up with CICE, and we're planning on doing that for the thermodynamics based on the new ICEPAC column physics, community column physics package. For the dynamics, we've kind of moved in the direction of making the sea ice model and the ocean model, MOM6, more compatible by putting the sea ice on the sea grid. So we're participating in 13 MIPS, and these are the MIPS we're going to be doing, and the models that we're going to be using for the experiments that are being run. And then there's an additional high-resolution version of CM4 that's being used for the high-res MIP. For as Alex said, SIMIP does not have specific experiments that are requested. Rather, it's a data request, and we are supplying all of the Tier 1 variables requested in the Knotts et al. Documentation paper. So we have a historical simulation of CM4 now, and we're very pleased with the simulation. We think it's a significant step up in quality from previous GFDL models. It has greatly reduced SST errors, improved top of atmosphere radiation. The precipitation is good. The double ITCZ is still there, but not as bad. The ENSO is very good in this model, including the teleconnections to mid-latitudes. And the Arctic sea ice cover looks pretty good. This is showing you the observations in black and 3-member ensemble of CM4 in red. The seasonal cycle looks good. And we're doing a pretty good job of capturing the winter and summer sea ice trend. So we were asked to come up with a question for discussion. So I'm going to switch over to my question for discussion, which is, does this agreement tell us that we have a good sea ice model? And Alex actually touched on this topic too. Between the previous two CMIPs, the sea ice simulation improved, but it wasn't because of the sea ice model, it was because of changes in the radiative forcing. And I think this is really a central question for SIMIP, is how do we go about seeing the impact of the sea ice model in the model simulation, which is sort of an emergent property of the model. And just to show you how bad things can be on this front, this is our experience in the last two IPCCs, between the last two IPCCs, of not doing anything to the sea ice model. So we use the same sea ice model for CM2 and CM3. In the lower left, I'm showing you the 21st century warming in the Arctic in the SIMIP6 models listed low to high. And GFDL is at both ends, right? So we have ESM2M and ESM2G with about 1 degree warming over the century at the left end, and then at the right end we have CM3 with over 6 degrees of warming. So that's with the same sea ice model. So there's a lot of potential for other factors to obscure the influence of the sea ice model in the actual behavior of the Arctic and even of the sea ice. The panel at right is showing you the sea ice extent in CM2 and CM3 plotted against global temperature. So the slope is kind of a sensitivity of the sea ice cover to global temperature. Again, it's the same sea ice model, but CM3 pretty consistently has about twice the sensitivity to global temperature change as CM2 does. And we now know that, or we now think that high latitude cloud feedbacks are a large contributor to this. So kind of indicates that if we're going to be able to see the influence of the sea ice in these solutions, we're going to have to do some more specialized analysis, looking at radiative feedbacks and things like that. I saw that on Alex's list. I should mention that there's also another experiment that should be useful for sea ice evaluation amongst the SIMIP6, and that's OMIP, right? So these are ice ocean configurations run with reanalysis forcing, all run with the same reanalysis forcing. So the nice part about this is there's good news and bad news. And the good news is that it eliminates this cloud feedback, which is such a bull in the china shop for us. But the bad news is that it also reduces the sensitivity. So there's a lot of papers where folks have taken sea ice models and changed the formulation, run experiments like this to see what changed. There's a tendency to not get very much sensitivity in those experiments because the air temperature is fixed. It's like you're treating the atmosphere as if it has an infinite heat capacity, and it doesn't really allow the sea ice to respond as much as it can in a fully coupled free-running climate model. So at GFDL, my colleagues and I are interested in pursuing another method of evaluation third method of evaluation for the sea ice model, and that is looking at the coupled model, but using initial condition experiments instead of boundary condition experiments like we use for CMIP. So these are forecasts. So GFDL has a forecast model, which we contribute to the NMME, and we also participate in the SIPN forecast exercise. And so we've evaluated the hindcast skill of that model, and it has some skill. And we've also done predictability work to evaluate the maximum possible skill, so we know how much further we can go with this, how much room for improvement there is. And that investigation has kind of led us to believe that there might be room for the sea ice model formulation to have some significant impact on the skill of the forecast, and that's shown here. So these are plots of skill for the East Siberian Laptev and Beaufort Sea, and the forecast target month is on the horizontal axis, and the lead is on the vertical axis. In the middle, I'm just showing you a simple forecast that's made. It's basically just the correlation between ice thickness in a month and then sea ice concentration in a later month. And you see there's an interesting triangular structure to the skill, such that our models are not very skillful when they're initialized before the beginning of the melt season. But after the melt season, suddenly we get, if we know the thickness, if we're able to track the thickness skillfully in the melt season, it seems like we can predict the sea ice concentration later in regions, not just Panarctic, but in individual regions. So we call this the May barrier. And it's kind of unfortunate because the sea ice thickness observations basically cease once the melt season begins. But what it does kind of suggest is that we may be able to improve skill by improving the physics of the melt season physics, basically, in the model. That's kind of what we're interested in working toward. And the panel at top is just the maximum possible skill. So this is showing you that basically this effect, this association between ice thickness and ice concentration at a later time is giving us most of our potential predictability. So I guess I'll just leave it there. I just wanted to mention, I think this sea ice model intercomparison is actually, I think, a very difficult topic. And I've been very kind of frustrated with it as a sea ice modeler, trying to convince myself that the sea ice model is actually good, not just in the formulation of the model, but also is it fit for purpose? Is it actually good at what we're trying to do with it? And so I just wanted to point out some of the challenges there. So I'll stop there.
Okay, thanks very much, Mike. Before we go to questions, I thought I'd let Dave have a minute or so to respond to your provocative questions here. Dave, do you agree with Mike's assertion that perhaps it's in the SIMIP configuration here, it's going to be difficult to tell issues about changes in the sea ice changes in the climate sensitivity based on changes in the sea ice model?
I agree. I certainly agree to a point. You know, we've always liked to say here that the sea ice is the canary in the coal mine, right? That we're responding to a lot of the forcing from the atmosphere and the ocean. I think, though, that SIMIP, what it allows us to do is still understand changes within different models. And maybe while we can't ascribe it all to just the sea ice model differences, I think there's still some interesting questions that we can look at by assessing the mass budget between the different components and, trying to look at the different fluxes. And I mean, if the answer comes out that we're getting different fluxes from the atmosphere contributing to the mass budget, I think that's still useful information in my mind. But I agree with Mike that it is, we are the canary. Okay.
Let's see if there are any questions from the participants here. Are there any questions?
Yeah, yes, I do have a question. Well, as Alex mentioned about the deadlines and things like that. So one of my projects actually to assess the models performance, and I looked at there are about 9 models so far as of today, but now the CS component from NCAR and the GFDL models are there. So I did have a communication with Mike by email. So looks like we're not able to get that before the March workshop. So I just wondering what something you are suggesting for us to do. Because especially for the NCAR model, that's one of my favorite. I really wish to see some of the results from you guys.
I don't have a response from that I'm happy to give. I mean, I wish the data were there, but it just isn't. We're delivering a lot of, now I'm going to make excuses. We're delivering a lot of data and doing a lot of documentation at the same time. I think one thing that should be mentioned is there's this ESDoc, which is a very good place to go for finding out what the model actually is. That we need to do as well. Yeah, we've struggled, like Dave said, we've also struggled at GFDL to get the metadata just right and get ourselves moving through the checkers. But I've personally QC'd all of the pre-industrial control sea ice data.
Okay.
And so it's ready to go. It's sitting there ready to go. Yeah. And I haven't seen I haven't been able to QC the other experiments because they just haven't shown up. It's a pipeline here at GFDL. I have to wait.
Right. So you mentioned which the other website we should look at?
ESDoc.
ES doc?
ES-doc, if you just Google that, I think you'll.
DOC?
ES, DOC, yeah.
Okay, thank you.
Yeah.
Mike, or Dave, how does this compare with the previous CMIP in terms of meeting the targets and getting things there?
Well, yeah, actually, that's a good question. My memory for that is gone. Maybe Mike has a better memory of that, but it seems like last time around, the whole process of converting from our native model information to the CMIP requested formats for everything was a terrible pain. I mean, we spent months and months just doing that post-processing. I think this time around, we've automated a lot more. And as I mentioned in my presentation, I've done as much as I can to actually write the requested variables directly from the SICE model, so that hopefully that cuts down on amount, some of the post-processing that's happening. But in response to Nguyen's question, we've started to try to push the data, and we're getting there. We've been running into some technical issues with it on our end. However, that said, we have a number of special issue papers specifically targeted at the CESM planned. And if you wish to be a part of those, you can get early access to the data that we have on Cheyenne. But then you would have to also be a part of our special issue papers to do that. And you're welcome to, as a part of the Polar Climate Working Group. So,
okay. Good to know that. Thank you.
Is there another question from the community? I don't see any on the chat. Melinda has left for a prior engagement. I wanted to make sure that I go through all of the suggested questions here. So if the results for SIMIP6 are different than SIMIP5, the primary reason for that would be X. What do you think the answer would be for that, Dave? Would it be a difference in the cloud forcing between CESM 2 and SIMIP5, or would it be primarily associated with something else?
I actually think in our model, at least, a lot of it has to do with the polar vortex and the changes in the circulation in the two hemispheres. We've certainly found that, the changes in the Beaufort High that we've had in our newer versions of the models have really allowed us to pile up the thicker ice over on the Canadian side rather than on the Russian side and things like that. So I think there's a big role for the atmospheric dynamics in this. But I do agree with Mike that the radiation is a key part of this as well.
Okay. Same question to you, Mike, then. So you had previously indicated the radiation. So
the question is about if the solution changed, why did it change?
Yes. Well, why would you, just as a guess, why would you think it had changed?
Okay, so I think the big change for GFDL was between CM2 and CM3 in the simulation of the sea ice. And I think CM3 had pretty good looking sea ice in terms of the trends. And CM4 is kind of like CM3. And like I mentioned before, I think it's really a matter of the high latitude cloud feedback being different. It has to do with the drop count that you simulate. We specify drop counts in high latitude drop counts. Well, drop counts everywhere in CM2, and we simulate them in CM3 and CM4, but we simulate tend to simulate kind of low drop counts, and that's associated with a less negative cloud feedback. But so, when we do that, we get a model that has nice trends, but I don't have a lot of confidence in that. By the way, these drop counts are not that well constrained by observation, so we don't have that to sort of hang our hat on. But I think the simulation will be pretty good in terms of its emergent characteristics, but are we getting the right answer for the right reason? I have less confidence in that.
So what do you mean by drop counts?
The cloud drop counts.
Oh, the cloud
number of
drop.
cloud nuclei. Yeah.
Mike, correct me, I thought I saw on one of your slides that you're using a fine resolution ice rheology. Is that just in development, or is that going to be used for the deck?
No, I think what you saw was that fine-grained ice-ocean dynamical coupling. So this, we have had problems at GFDL because the ice actually exerts pressure on the ocean. There's the potential to get unstable waves. And this is just a way of reducing that for the future. But actually the model has been very stable in its current configuration. Much more stable than CM2 was. This doesn't matter to you guys, but for folks here, it matters a lot. So that's not going to impact the simulation. I don't expect it will.
Okay.
This is Hailong Wang. I have a question about for Dave and Mike about the snow and ice impurities. I know that is included in CIS5, but I don't know if it's turned on. And also for GFDL model, do you consider those?
Yeah, we definitely do have black carbon and dust impurities in the snow and ice. That is turned on, and it's coupled to the atmospheric model's prognostic schemes for those.
Okay, thank you.
Yeah, so this is another way that we're behind NCAR a little bit here. We don't have that yet.
All right, thank you.
Okay, we've gone a little bit over time. Should we wrap it up here, Meredith?
Yeah, if no one has any other questions, I think it's a good time to wrap up.
Okay, well, I think this was a great discussion. I certainly learned quite a bit here. So next time, the modeling sub-team will be looking at the land ice MIP. Melinda's not here, so I don't know what the sea ice team has planned for next month. But that's where things are.
Yep, I don't think the sea ice team quite has a plan yet. I could be wrong, but okay.
No, I don't think you're wrong.
We're all still catching up, it seems. Okay. Thank you, Richard, and everyone for joining and being part of the discussion. We'll post this recording on our website so you can revisit it if you want to catch anything that you missed.
Thanks very much to the speakers.
Thank you.
Thank you.
Yeah, thanks.
Thank you. Bye-bye.
Bye.
Bye.